Periodic motion, questions 10, 11 and 12. Question 10. The frequency of a body moving with simple harmonic motion is doubled. If the amplitude remains the same, which of the following is also doubled? To answer this question, you need to think about the relationships between variables, and that's likely to be best achieved by using equations which are available to you on the data sheet. So first of all, what would be the consequence on the time period of doubling the frequency? Well, the time period is the reciprocal of the frequency, so doubling the frequency would halve the time period, so this is simply not correct. Next, you can consider the total energy. The total energy is the same as the maximum kinetic energy, which would be a half m Vmax squared. Also, the maximum speed or velocity is given by Vmax equals omega a, where omega is 2 pi f. This means that the kinetic energy, since it's proportional to Vmax squared, it's proportional to omega squared, it must be proportional to f squared. So doubling f would give you 4 times the total energy. So this is not correct. The next one, the maximum velocity, we've almost already answered now. So Vmax is equal to 2 pi f times a. So whatever you do to the frequency, the same outcome will happen for the maximum velocity. So double f, double Vmax. This is the correct answer. Finally, you can check the last one. The maximum acceleration is given by this equation. Once again, we have omega squared, so that means the acceleration is proportional to f squared. So doubling f would give you 4 times the maximum acceleration. So this is incorrect. Next, we have a body moving with simple harmonic motion. We are told the amplitude is a and the frequency is b divided by 2 pi. What is the magnitude of the acceleration when the body is at maximum displacement? The general equation for acceleration is minus omega squared x. Maximum acceleration will occur when the displacement x is its maximum value, in other words, the amplitude. And since we only want magnitude, we can ignore the negative sign. So omega equals 2 pi f. We can square all that and multiply by the amplitude. Then the next line, we can substitute in the value for the frequency, which is squared. The 4 pi's cancel, and you can recognise answer C. Finally, two pendulums, P and Q, are set up alongside each other. The period of P is 1.9 seconds and of Q is 1.95 seconds. This is similar to the last part in question 7 that you may have looked at earlier. You are asked for how many oscillations are made by pendulum Q between 2 consecutive instants when P and Q move in phase. So P and Q are in phase on release, and they will become in phase once again. I've just recorded the 2 time periods in a visual way to help me process the information, and we can appreciate that they are going to be next in phase when P has completed 1 more oscillation than Q. Since it has the shorter time period, it will need to have 1 extra oscillation to eventually fall back in phase. So we have here that P will have n plus 1 oscillations and Q will have n oscillations. Q's oscillations last for 1.95 seconds, whereas P's oscillations are only 1.9 seconds long. So these two times must be equal, and we can then process the algebra and solve to find n is 38. Notice that the answers 38 and 39 are both given in the question. Do be careful. You're asked for how many oscillations are made by Q. Q was the pendulum with the longer time period, so it makes the smaller number of oscillations, which is 38.